Hey engineering students, welcome back to part 2 dealing with this heating tube. So last time we left off right after we had completed the sweep and revolved to make that taper. What's next? Well, we need to shell this thing out to hollow out the tube. The shell size should be the difference between the outer radius and the inner radius, but we have to watch out because the diagram from page 2 is showing us diameters instead of radii. Be sure to select both ends so that they are open. Yeah, because we want this thing to be a completely hollowed out tube. So if we look back at page 2 where these diameters are being shown, right, we want the shell size to just be that difference. But we need to make sure that it's happening just on each side, one side at a time. So to find the radii, right, we could take the diameters, divide by 2, okay, and then subtract. Or we could subtract the two diameters, find the difference, and then divide by 2. It works both ways. So here in Onshape, to apply this shelling, we need to select the shell tool from our toolbar, and I'm going to specifically remove this face and that face, and the shell thickness, right? I don't have to do the calculations. I can simply tell it, hey, take 0.375 minus the 0.27 and then divide it by 2 to deal with this radius issue. So I'm going to go ahead and hit enter to see a kind of test piece. So that really looks pretty good, and green check it. So this thing truly is hollow all the way through. I know it might be hard to see. So if you're wanting to look at it from a section view standpoint, go ahead and show these analysis tools and select not that. Sorry, it's up in our camera and render options. Here's the section view all the way at the bottom of it. So if I select a plane, such as the right plane, and drag my arrow back so that I can see farther into this thing, all right, I can see, hey, here are my section lines. That's the solid material. This is open because it's a hollowed out tube, right? If you want to hit the check mark to really see it, that works great. If we want to make it go away, check out those options again and turn the section view off. So our tube is totally hollowed out. That looks awesome. What else is there? Well, we do still need to add those threads. So I'll just double check. We did the shell. Threads. A thread feature allows you to model threads on a cylindrical curved surface. An external thread is a thread created on the outside of a cylinder, such as on this bolt. An internal thread is a thread created on the inside of the hole, like the threads inside a nut. All right, the diameter of the cylinder or hole must match the nominal diameter of the desired thread form. So we had created the tube to be 0.375 inches on its outside diameter, and we had to do that because the diagram shows us that we aren't selecting threads that are 3/8 of an inch, so that's the outside diameter, and then the dash 16 is 16 threads per inch. So that's how many threads we would see if we had a full inch. This is only a 1/2 inch in distance, so there should be 8 threads here, so 8 turns essentially. And UNC is a code in ANSI standard, and then 3A happens to be a specific size for the pitch of it. Okay, so what does this say below? Use an external thread for ANSI standard threads, 3/8 inch. It matches the diameter of the pipe, and 16 threads per inch. You will not be able to see the threads on the model, but you can see that they're there in a drawing file. Yes, it's really kind of a bummer. And Onshape is only capable of doing external threads. So this is at least a new feature. They have been adding features over the last couple years. It's not perfect yet, but it's getting better. So right on this part of the pipe, that's where we need to put these threads. So I can see mine. It's right here on my toolbar. So go ahead and click external thread. Select the cylinder edge. Okay, so it does have to be an edge, not just the outside of the pipe. So select that edge where it's going to go from. Make sure it says ANSI as the standard. And then you might have to, look through because we're trying to find 3/8 of an inch. It might find it by default. Make sure 16 TPI, threads per inch, is chosen. Make sure you select blind and make sure the length is 0.5 inches. We don't need to add a chamfer that puts like a little, cut edge on the end. We don't need that. We also don't need an undercut, which stops and separates the threads from the rest of of the pipe. So we don't need any of that, but go ahead and click the green check. Yeah, looks really super lame. It did nothing. I see it here. It's black, so there's no error, but where is it? Well, I did find a way that you can look at it-ish. If you select that, right, it is a separate piece. And then I went to the analysis tools and chose curve/surface analysis. And so it is kind of showing or indicating that there is something there. Okay, it's just really unfortunate that there's no other way to see it. But if you right click to create a drawing of part 1, make sure it's in inches, make sure it's 4 views. Let it think a little bit. When it puts it in the front view of the multi-view, it shows these dashed lines here, which are not hidden lines, but this is identifying the threads. So that if we were to select the hole or thread callout, you should be able to find it on your toolbar. Hole and thread callout. There it is. Hole and thread callout. We should be able to select that edge, and sure enough, it gives us the 3/8-16. Okay, so it is there. It is present. It's just it's just not going to give us the visual of it like I would like to see. So that's kind of a bummer, but like I said, it's better than it used to be. Okay, so I think that's it for, that was it for finding and creating this entire sweep, tapering, shelling, and the threads on this particular heating tube. So great work, hang in there. There is one more part to make. I'm hoping that you're able to figure that one out after all of these tools have been used.